In this video, we will learn about how to use Roy's identity in finding out the Marshallian demand function. So this question is in continuation to the earlier question where we have proved that the indirect utility function will be this stuff. Okay, so let me repeat the question. Assume a consumer with utility function in the form of, we have the utility function for a consumer, that is u is equal to x1 x2 divided by x1 plus x2. X1 and x2 are the two goods and u denotes the utility. We were told to prove that indirect utility function for the consumer will be equal to, that is v is equal to m upon P1 plus P2 plus twice under root P1 P2. M denotes the income of the consumer. Okay, this part we have explained in the earlier video in detail. Okay, so I will not be able to solve it again. Okay, now we are being told use Roy's identity to derive Marshallian demand function for good x1 and x2. Okay, we need to find out the Marshallian demand function for good x1 and x2. Okay, so actually these are the Marshallian demand functions, okay, which we need to find out. We have calculated or derived these two demand functions earlier in that video. Okay, but this time we are being told to use the indirect utility, use the Roy's identity to derive these Marshallian demand functions. Okay, and this is our budget constraint obviously. Okay, so how do we proceed to this question? So how do we use Roy's identity? Roy's identity is useful, okay, when we are being given the indirect utility function and we are being told to extract the Marshallian demand function from the indirect utility function. Okay, so this is our indirect utility function. Let me write it here. Our indirect utility function is m, which we derived earlier. Okay, you can check that very video. I have explained that very and in that very video in detail. Okay, p1 plus p2 plus twice p1 p2. Okay, so the question could be like this. Okay, the example of this question will be like this, that a consumer's indirect utility function is this. Okay, how can you derive the Marshallian demand function when we are being given the indirect utility function? Okay, for that we use the Roy's identity. Okay, so if we use the Roy's identity, we should get these two demand functions. Okay, so how do we incorporate the Roy's identity here? Okay, Roy's identity is being given by, let me write it here. So Roy's identity, I don't know what is the spelling here again. Mashid, IDENTITITY, IDENTITIT क्या था इन्हें? Okay, so basically the Roy's identity tells us if we are being given the indirect utility function. Okay, indirect utility function, obviously that will be the function of p1 p2 and income. Now Roy's identity tells us that the demand function for good x1 will be equal to the partial derivative of our indirect utility function with respect to p1, okay, minus sign, divided by partial derivative of our indirect utility function with respect to income. This is our Roy's identity, which gives us the demand function for a good x1. Okay, obviously the Marshallian demand function. By Marshallian demand function, what we mean, simply when the consumer's demand function, when the consumer consumes a good which is a function of prices and income, we call that very demand function is Marshallian demand function. In case of Hicksian function, our demand function will be a function of utility and prices. Okay, so let us solve this very question. So using straight going straight with this Marshallian demand, Roy's identity, that means our x1 Marshallian demand function will be equal to the partial derivative of our indirect utility function with respect to price p1, okay, and here is minus sign, divided by, let me write it like this, divided by the partial derivative of our utility function with respect to income. Okay, this is our application of Roy's identity. Okay, it helps us if we are simply being given the indirect utility function to extract the Marshallian demand function from that very utility function. We use the Roy's identity. It actually saves a lot of time. Okay, so going straight forward. So let me rub this out. I will need this very space. Okay, so we need to find out the two derivatives. Okay, dv upon dp1 and dv upon dm. Okay, so let's try to solve out this. So let us first calculate dv upon dp1, then after we will use this very sign. So let me see if I have the space here. Yes, I have. So dv upon dp1 implies we need to take the partial derivative of this indirect utility function with respect to price. Okay, here we have two functions. This is, in numerator we have m and in denominator we have the prices. How do we solve this very, how do we take the partial derivatives when we are being given two functions? Let us say we have a function of y. Let us write it like this. If we have u is equal to f of x upon g of x. Okay, if we have two functions, then how do we take the partial derivative? So taking partial derivative means, let me write it, u dash will be equal to, so we use here quotient rule. First we write the denominator function. To this we multiply the derivative of numerator function, that means f dash x. Then we write minus and write this numerator function, and to this we multiply the derivative of denominator function g dash x divided by gx. You can find out this very formula in standard textbooks. Very simple. That we have to use here. So in place of this is our f of x. Okay, and this whole stuff is our g of x. Now let's use this. So first we write g of x. So g of x is this p1 plus p2 plus twice p1 p2. Okay, then we need to take the derivative of this function, that means d upon dp1 of m. Okay, we have here m, let me write it here m, then minus we write this m. Okay, this f of x, and take partial derivative of our denominator function, that is g dash x. That means the derivative of this function, that is p1 plus p2, okay, plus twice. Okay, let me rewrite this here. Okay, so this can be written like this. I can write it like this: p1 raised power 1 upon 2, p2 raised power 1 upon 2. Okay, ये go very whole, and we write this g of x as it is, that is p1 plus p2 plus twice p1 p2, and take whole square of this. Okay, so this function as it is. Now the derivative of m with respect to p1 will be obviously 0, because we are taking the derivative with respect to p1, and p1 is not here involved, so derivative of p1 will be here 0. So 0 times any stuff will be equal to 0, so this whole stuff will become 0. Okay, that means we are left with minus m. Okay, now derivative with respect to p1 this time. So derivative of p1 will be 1. Then we have p2, its derivative will be 0 because we are partially taking different derivative with respect to p1. Now the derivative of p1 in this case, so we have p1 raised power 1 upon 2. So its derivative is simply this 1 upon 2 will become coefficient. We have p1 and exponent will be subtracted by 1. So this will become 1 upon 2 p1 minus 1 upon 2. Okay, and we have the 2 here. Okay, if I write this 2 and 2 will get cancelled, so we are left with p1 raised power minus 1 upon 2. Okay, and this can be written like this, 1 upon p1 raised power 1 upon 2. Okay, simple stuff. So derivative of this will be equal to this p raised power p1 raised power 1 upon 2, and this can be, okay, let me write it as it is. So we have plus, so then we don't have this 2 and this exponent, when it formed the coefficient got cancelled. We are left with this 1 upon p1 raised power 1 upon 2, and we have p2 as it is, raised power 1 upon 2. Okay, I hope I am making myself clear. Then we have this stuff, that is p1 plus p2 plus twice p1 p2 whole square. Okay, so let me write it here now. Okay, this is one learn. This stuff will be equal to, which is equal to minus m. Then we have this 1 plus, I can write it like this again, p2 upon p1. Okay, so you should not have any difficulty in learning this here. So using this root here, divide by p1 plus p2 plus twice p1 p2 whole square. So we have here minus m, and this can be written as p1 plus p2 divided by p1 whole divided by this p1 plus p2 plus twice p1 p2. Okay, now what should I do? I will rub this out. Okay, to make the things easier. So our dv upon dp1 will be equal to minus m, okay, which we wrote, we have under root p1 plus under root p2 divided by under root p1 whole divided by p1 plus p2 plus twice p1 p2 whole square. Okay, then our this dv upon dp1, that means minus dv upon dp1 will be equal to, okay, so if we give minus on LHS side, we have to give minus here also. So this minus and minus will become plus, so we are left with m. Then we have this under root p1 plus under root p2. Okay, then we have divided by under root p1. Okay, this p1, and we have this p1 plus p2 plus twice p1 p2 whole square. Okay, this is our dv upon dp1. Now what is our dv upon dm? Another derivative, that is dv upon dm because we are using the Roy's identity. First we need to find out the derivative of indirect utility function with respect to P1, and then the derivative of indirect utility function with respect to income. Okay, so this is our indirect utility function. Dv upon dm means taking derivative of this function with respect to m. So m we have in the numerator. It is very simple. The derivative of m is 1, so we are left with 1 upon p1 plus p2 uh, plus twice p1 p2. Okay, so we don't need to use the quotient formula here. So we got two things here. This x1 will be equal to minus dv upon dp1. That means our x will be equal to, then x1 will be equal to minus dv upon dp1 divided by dv upon dm. Okay, minus dv upon dp1, we got this very stuff, that is m under root p1 plus under root p2. Okay, divided by this under root p1, and this stuff p1 plus p2 plus twice p1 p2 whole square. Okay, divide by whole divided by this dv upon dm, that is 1 upon p1 plus p2 plus twice p1 p2. Okay, now we can do one thing, since these terms are same here. Okay, in the brackets I can cancel this thing and this thing here, so I will be left with that is x1 will be m under root p1 plus under root p2 divided by under root p1, then we have p1 plus p2 plus twice under root p1 p2. Okay, I hope I am making myself clear, because here it was square. Also, okay, one term will left here. Now doing some further simplification. So we have x1 is equal to m, we have under root p1 plus under root p2, okay, divided by under root p1 here, and this setup, this is a square plus b square twice a into b. This becomes under root p1 plus under root p2 whole square. Okay, this stuff I have used the formula which you know from your mathamal, that is a plus b whole square is equal to a square plus b square plus twice a b. Okay, so in place of a I have written under root p1, under root p1. In place of b I have written under root p2, and you can see it will be equal to these terms here. Okay, that means our x1 will be equal to, so one term will get cancelled, we are left with m upon under root p1 into p1 plus p2. Okay, and if we further simplify this, simplify this, so we will get x1 is equal to m divided by under root p will be p1 here. Okay, so sorry, under root p1 plus, now under root p1 under root p2, we have under root p1 into under root p2. It can be easily written as under root whole under root p1 into p2. Okay, so this is p1 into p2. Okay, so after a long journey, we got the Marshallian demand function for good x1 using the indirect utility function. X1 is equal to m upon p1 plus under root p1 p2. We got same result, that is x1 is equal to m upon under root p1 plus p2. Okay, so this is how do we use rise identity. Similarly, you can find out the demand function for good x2 using rise identity. I will not write it here, so it will become very lengthy. So to find the x2, we just need to take the derivative of indirect utility function with respect to p1 and divide it by, so let me write it here, x2 divided by derivative of our indirect utility function with respect to m. Sorry, with this time we have to take this with respect to p2. Okay, and then you have to take the derivative of this utility function, indirect utility function. It will take very lot of time. Okay, but you will get the step, that is x2 will be equal to, that is m upon p2 plus under root p1 p2. Okay, this is an assignment for you. How do you calculate the demand function for good x2? I have calculated for good x1 using all this stuff, so you can calculate this very stuff. Okay, I hope I make myself clear in this video. Thank you. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.